Yeah, good morning everyone. In this tutorial, in this video, I'm going to discuss about lambda expressions. So what are lambda expressions? First, to understand what is the lambda expression, we need to understand what are functional interfaces. So we are going to discuss about lambda expressions and functional interfaces in this video. In Java 1.8, Java came up with functional programming touch in Java. So Java took the functional programming concepts into Java 1.8 and introduced many of the functional programming features. One of the feature is Lambda expression. So to implement Lambda expressions, Java introduced a concept called functional interface. Uh, First, we see definition. What is a lambda expression? So lambda expression is a anonymous function which doesn't have any name, but it has a body and it can take the inputs like a method and it can return some value. So if you see the lambda expression, it exactly starts at the method and it ends in the method body only. We will go to the Eclipse and we will see with example the functional interface and how the functional interface will be implemented using lambda expression. Let me take one interface. Addition. I want to add two numbers. So in this addition, I have one method, public int and add b. This is my interface method. So this is abstract method. In general, in interfaces, we can have more than one abstract method, but as per definition of functional interface, we should have only one abstract method. If we have more than one abstract method, it not considered as a functional interface. And to protect our functional interface, we can annotate with address functional interface, so that this annotation will take care of modified behavior. If somebody want to add one more interface, it will raise a flag saying it is not a functional interface as you are added a few more methods. Yeah, here you can see the error. Okay, so now we are ready with the functional interface. Now how many ways we can implement? One way is we can create one class which is implemented to addition interface, and we can provide the behavior for add method. That is one thing. It's a regular way. And alternate ways, we can use anonymous class where we can override add method and we can provide the behavior then and there itself inside a class. That's a second thing. Third way is to use lambda expressions. So first we see using anonymous method class, and from that we will derive how we can implement the lambda expression. Yeah, let me create a class which is like a calculator. Yeah, in this calculator I want to use add method addition. So to use add method to add two values, I need to implement addition interface. So how can we implement addition interface? Using anonymous, let's say add. This is the reference variable and this is the method I need to override. Okay. Here I am taking one variable and I am adding two numbers. Okay, I am writing this number. Yeah, this is my business logic. So this is anonymous class, and how can I call this? Dot add, and I have to pass the variables. So it returns some results, addition value, and we can print this. This is the typical behavior of anonymous in a class, which is anonymous class, which is implemented to an abstract class. Here, what is the problem? The problem is we have the business logic here. This is the business logic, which adding two numbers and returning value. But to do this, we have to create a class instance, and we need to provide a method with the signature, and we have to take care of so many things, and so many syntax we have to write. So to avoid all these, and Java has came up with Lambda expression, which removes all boilerplate code. These all things are not required. Lambda expressions, the logic starts here and ends here only. We'll see with the example here. Let's say I'm creating a Lambda expression, so the signature is something like this. Here we need to provide the inputs. The inputs are a comma b, and this is the syntax we have to use. This is the Lambda expression syntax, and here my behavior. What I am doing, I am adding two numbers. So just a plus b. So it's single line code, no need to use return keyboard. This is the object, Lambda object, or this is the implementation to a addition interface. Addition interface has a add method, and add method is doing adding two variables by taking inputs a comma b and returning some int value. So my Lambda expression object also doing the same thing, and Lambda class also doing the same, taking two inputs a comma b and adding those two values and returning those value. This is the object. Then we need to refer with some reference interface reference. Yeah. How can we call this Lambda expression? Lambda expression is referring with d reference variable, so d dot add, and I can pass some value, and it's returning some value and storing here and putting this one. Yeah, let me run this and see. Yeah, we got out. So that's all. To create Lambda expression, this simple, and just calling this as a normal Java object calling. So what is the advantage here? The advantage is we are removing all boilerplate code, and we are just concentrating on this business logic implementation. Okay. We'll go with the other example which we frequently use, which is a runnable interface, and we'll see. We will use the runnable interface to create a thread. So I'm going to create a runnable. Yeah, this is an anonymous class I am creating and assigning to a reference. And this is the run method we are overriding. So here I am just logging nothing. Then I'm creating thread. And here I'm passing run and start. Yeah. Now I'm running this. So to create a thread to implement run method, runnable, we have to write this much code. So we will see using Lambda expression how we create this one. Using Lambda expression, this is syntax. run method is not taking any input. Here run method is not taking any input, so this is empty. And inside run method, what we are doing, we are printing. So just that's all. This is the run method, runnable interface implementation. And this is a runnable interface implementation. So this is a class object. So object is referring with one reference R1. Now we can use a thread and we can start. So this is a T1, and here R1. R1 is a runnable. Let's see. I will give different one something. Okay. Yeah. So this simple to implement runnable. Just one line is enough, as we have business logic of one line. This one is coming here, and these are the inputs. So there is no input, so it's empty, and it's a single line, so there is no braces required. If you want to write multiple lines, then we need to keep in a braces, and yeah, it's a wide method, so we don't use any return statement here. And multi-line, then we'll use a semicolon for end of the line. Yeah, that's it. The advantage we are getting is we are avoiding so much boilerplate code, and we are concentrating on business logic. That is the main advantage we will see in Lambda expressions. And we can eliminate anonymous class implementation, and we can go with the Lambda to make a cleaner code. And one more thing I can discuss here. I am saying this is a Lambda expression implementation class. How can I say it's a Lambda expression implementation class? We can just print what is the instance. So R1, I am saying R1 is a implementation for runnable using Lambda expression. So I am checking instance of runnable. So it should give true if it is implemented. And I am commenting this just to avoid confusion. See, we got true, means whatever implementation we have done using the Lambda expression, that is implementation for runnable. Yeah, that's all. Thank you for watching, and please do subscribe my channel.